Okay, some exciting updates this last week for the DUT Hub. The first thing I did was build this test jig to kind of do a full end-to-end testing of a 4-device panel. I also got MicroPython working, which makes testing and creating tests much easier. So let's take a look at how that works. So the device here is just a simple LED on a PCB. And what I'm doing right now is running the test suite, which turns on the LED for each board sequentially, measures the current, and gives you a pass-fail result. So in this case, all the devices passed, so that's great. The DUT Hub is the same as last week. No changes to the hardware, other than I got MicroPython working on the test MCUs. And here is the test jig I made for the PCBs. So this is just something I handmade on some MDF and some brass standoffs. So the MDF holds the Pogo pins, which go through the lower PCB, which is acting as a guide so that they maintain their position, their vertical position. And then finally, they reach the top PCB, which is the actual PCB that we're testing. So normally, you would make your guide out of acrylic or some ESD safe material. But in my case, it was just easier to use a scrap PCB. So the toggle clamp pushes down on the 1/2-inch acrylic, which moves that top PCB down and is able to do that because it's sitting on a bed of springs. So on the top there, I have some PLA plastic parts, just some scrap I had lying around. Those are acting as weight distributors. So normally you would have screws or something that's designed specifically for your PCB to evenly distribute the weight. But in my case, I didn't want to go through the trouble since this is not something I'm putting into production. This was good enough just to sort of see how it would feel like. Okay, the test jig itself is made out of aluminum extrusion, 1/2-inch thick acrylic, and linear rails. No specific reason for choosing these parts other than it's what I had on hand. It's probably overkill for this, and it's quite heavy, but it was good to sort of see what it feels like in real life. So the 1/2-inch acrylic is important because once you have a lot of Pogo pins, you start actually needing to apply a lot of force, and it needs to be strong enough to not bend or anything like that. The toggle clamp comes down and applies pressure and allows that top pressure board to move everything down. You can adjust the amount of pressure, of course, by turning that bolt there, which is really convenient. So you can sort of align everything and figure out beforehand how much you want everything to move down. This top acrylic board can actually move up and down on that aluminum extrusion. So that's really handy if you have like a much taller device you need to test. Okay, here's the actual test jig. And the top board is the board that we were testing, of course. It's just a PCB with an LED, 4 devices per panel. Here's a picture of the kind of bed of springs, which are aligned by these brass rods, which act as our guide pins. And that all sits on MDF. And our guide PCB is sitting on standoffs. Okay, if we disassemble it, we can take a look at the Pogo pins on the bottom. So the Pogo pins and the brass aligning rods are just fitted into the MDF through friction. The Pogo pins are soldered directly onto the wires, which then go to the DUT hub, and that scrap PCB acts as our aligning guide for everything. Those were just drilled out so the holes are a little bit larger so the Pogo pins can actually fit through them. On the actual PCB itself, the Pogo pins don't go through and just make electrical contact. Okay, let's take a look at the software to wrap things up. So I've uploaded the MicroPython port for this board to GitHub. I'll provide more documentation on how to flash the device, compile the software, etc. Let's also take a look at the test suite used to run the tests. So here's the command that you would run on your PC to test 4 boards sequentially. It's pretty self-explanatory. The test suite takes a test class, which you would write. In this case, I have an LED current test, which turns on the LED on the board and then measures current. If we take a look at that test suite here, here's the class, and we set our different parameters. And here's the interesting bit, which is the MicroPython. So we're sending MicroPython code to the DUT, and that's what's being executed to run the test. The interesting thing about this is you could potentially run this headless. So you could upload the MicroPython to your device, have it output to an LCD, for example, and give a pass-fail status. That would require some kind of output device like an LCD, which I may add in the future or the next revision. Okay, after that, we return the results to the test report. You get the test report in the command line that shows you pass or fail. Okay, that's it for today. If you have any feature requests, please put them in the comments. I'll likely be doing another revision of this board in the coming weeks. But for now, I'll see you on the next one.